Welcome to Daily Papers.
So let's talk about something we all experience, the temperature in our homes and offices. You've got the heating, the ventilation, the air conditioning, what's known as the HVAC system.
Ah, yes, the source of countless office arguments. One person is freezing, the other is melting, but behind that thermostat on the wall is a system that uses a massive amount of energy.
A truly massive amount. The paper we're looking at today notes that buildings account for about a third of all energy used globally, and HVAC systems, they're responsible for almost half of that.
That's a huge number. If we could make those systems just a little bit smarter, a little more efficient, the energy savings would be enormous. And that's exactly where today's paper, Building2Building, comes in. It's about using artificial intelligence to tackle this problem.
Right, specifically a type of AI called reinforcement learning, or RL. You can think of RL like training a puppy. You give it a command, and if it does the right thing, you give it a treat. If it does the wrong thing, no treat. Over time, the puppy learns what it's supposed to do to get the most treats.
So for an AI controlling an HVAC system, the treat could be a reward for keeping the temperature comfortable while using the least amount of energy possible. It learns through trial and error what the optimal settings are.
Exactly. And AI researchers have gotten really good at this. They can train an RL agent to perfectly control the HVAC system in one specific simulated building. It learns every quirk of that building and becomes a super efficient specialist.
But there is a catch, isn't there? What happens when you take that highly specialized AI and try to put it in charge of a different building?
It often fails, sometimes spectacularly. It's like a chef who has spent their entire life perfecting a single recipe for a single oven. Move them to a new kitchen with a different oven, and suddenly they're burning everything. The AI has memorized the rules for one environment, but it hasn't actually learned the general principles of heating and cooling.
That's the core problem this paper is trying to solve: generalization. How do you train an AI that can work in any building, not just the one it was trained on? The authors argue that a big part of the problem is how we test these AIs.
Yeah, they talk about benchmarks. A benchmark in AI is like a standardized test or an obstacle course. It's a way to measure how well different AI models perform on the same set of tasks. The problem is, most existing benchmarks are for things like video games or robotics.
They're not very diverse or realistic for a problem like this. Training an AI on those is like preparing a future architect by only letting them play with one type of Lego block. They might get good with that one block, but they won't be ready to design a real building.
That's a perfect analogy. The researchers realized that to build a general-purpose HVAC controller, they needed a much better gym for the AI to train in. So they built one. It's called Building2Building, or B2B for short.
So what is B2B? Is it a collection of real buildings?
Not quite. That would be incredibly expensive and slow. B2B is a massive suite of highly realistic simulated buildings. They use a state-of-the-art simulator called Energy Plus, which is so accurate that AIs trained in it can often be deployed directly into real-world buildings and work correctly.
And the key here is diversity, right?
Absolutely. The B2B suite doesn't just have one or two buildings, it has thousands. We're talking houses, restaurants, warehouses, small offices, medium offices, all with different layouts, different insulation, different window sizes, and located in 16 different climates across North America.
Wow, so instead of training in one predictable kitchen, the AI chef is suddenly doing a boot camp in thousands of different kitchens all at once.
You got it. The idea is that by training on such a wide variety of buildings, the AI is forced to stop memorizing and start actually learning the fundamental physics of how buildings heat up and cool down. It has to generalize.
So B2B provides the environment, but how do they actually test if the AI is learning to generalize?
They set up a series of challenges, each designed to test a different kind of adaptability. The first one is called goal adaptation.
What does that mean?
It means changing the AI's objective. For example, the AI might be trained just to keep the building at a perfect 21 degrees Celsius, but then suddenly the goal changes. Now it has to keep it at 21, but also save as much energy as possible. the reward or treat system changes, and the AI has to adopt.
Okay, that makes sense. What's the next challenge?
Dynamics adaptation. This is where the AI is trained on, say, 5,000 different simulated houses, and then it's tested on a brand new house it has never seen before. It has to take what it learned from all the other houses and apply it to this new environment with different thermal properties or dynamics.
And then there are even harder tests. The paper mentions something called action space shifts. That sounds a bit technical.
It is, but we can simplify it. Imagine you learn to drive an automatic car where you only have a gas and a brake pedal. That's your action space. Now someone puts you in a manual car. Suddenly you have a clutch pedal and a gear stick. Your action space has changed. The AI might be trained in a building where it can only control the airflow, but then it's moved to a building where it has to control the airflow and the central boiler temperature. It has to learn how to use these new controls.
That sounds really difficult. And I see there's one final, ultimate test.
Yes, cross-domain transfer. This is the final exam. Can an AI trained exclusively on a fleet of retail stores and restaurants successfully control the HVAC system in a large office building? It's a completely different type of building, a different domain.
So it's about seeing if the skills are truly transferable to a new and different context.
Precisely. And by creating this challenging, diverse, and realistic testbed, the researchers are giving the AI community the tools they need to build agents that can actually do this.
Which brings us back to the big picture. This isn't just a cool academic exercise in making AI smarter.
Not at all. The societal implications are huge. If we can create a single, generalist AI model that can efficiently manage the energy in any building it's put in, we could deploy it at a massive scale.
Instead of needing a custom-designed, expensive control system for every single office building or warehouse, you could have an AI that adapts on the fly.
And that could lead to a significant reduction in global energy consumption. It's a direct contribution to fighting climate change. The Building2Building benchmark is essentially a foundational tool, paving the way for AI that not only works in a lab, but works in the real world to solve a real, pressing problem.